So question 13 from assignment electrode potential and the transition metal. This question is about the compound of copper. When copper 2 sulfate solution is mixed with potassium iodide, the copper 2 ions are reduced and the products are mixture of iodine and potassium sulfate in a solution and a white precipitate of a copper compound. Write an ionic equation for a reaction between copper 2 ion and iodide ion, and you don't need a state symbol, they are not required. So when copper 2 sulfate, so copper 2 sulfate is there, like we have CuSO4, it's mixed with potassium iodide, it mixed with Ki. As a result, it produces, like copper 2 ions are reduced and the products are a mixture of iodine. So it has potassium sulfate, it has iodine, and it has here copper is reduced. So what is the lower oxidation, like copper reduced to copper 1 or copper 0, which is a copper metal, but they did not mention, they mention a copper compound is formed. So this will be copper 1 and then iodide, so I. So this will be aqueous, this will be aqueous, this will be aqueous, this will be aqueous as well, iodine molecule dissolved, and this was a precipitate, so solid. So what will the ionic equation? First, we should balance the equation as, or we just cancel out the common ions. Sulfate ions are common, so we cancel them. Potassium ions are common, so we cancel them. So what we have? We have copper 2 ions react with iodide ion. As a result, it will produce iodine and copper 1 iodide. Then we have to balance the equation. So if I put iodine, we have to balance. So if I put 2 here and 4, so if I put 4, iodine is balanced and copper is also balanced. So this is a balance equation when copper 2 ion reacted, as I mentioned, ionic equation for copper 2 ion and iodide ion. As they already mentioned, it is forming iodine molecule and they specify that copper 2 ions are reduced. So copper 2 ions are reduced to copper 1. Then write an electronic configuration for a metal ion in a white precipitate. So in a white PPT, we want to write like for copper basic here. And for copper, it is when you check the periodic table, so when we check the periodic table, copper is a transition element with 29. Copper atom is 29. So, but if copper is plus 2, it loses 2 electrons, so it will be 27. But copper plus 1, it loses 1 electron, so it will be 28. So we have to write for copper plus 1 because as I mentioned, in a white precipitate, and why it is white in color, like copper 1 iodide is white in color because it does not have incomplete d orbital. So when we write the electronic configuration for, if I first write the electronic configuration for copper, which is 29. So 1s2, 2s2, 2p6, 3s2, 3p6. Then it will go to 4s2 and then 3d, 29, so 9, and then they arrange. So it will be like we arrange them in, this is in terms of the energy, but we arrange them in terms of order. So it will be 3D and like in 3D9 is there and 4s2 because 29. Now what happened when the copper, this is a copper atom, when it loses electron, like it loses 2 electron, it will lose both from 4s. But when it lose 1 electron, it will lose from 4s, so this will become 1. But because to gain the stability, this electron jumps back to the d orbital. As a result, what will happen? It will become 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s 0. Like there is no electron left with a copper. This is copper atom. This one is copper plus 1 ion. That's how we write the electronic configuration. So it will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10 and 4s. 0 is there, or you don't write, that is also fine. Give the formula of a stable ion of an element in period 4 of a periodic table which is isoelectronic with a metal ion in the white precipitate. So isoelectronic means they have the same number of the electron. So basically copper plus 1 ion is having 28 electrons. So which ion in the period 4? So first we check that this is period 1, period 2, period 3, and this is period 4. So we want 29 electrons, 28 electrons. So copper plus 1 is 28 electrons. So we want to check which will have 28 electrons. Zinc is having 30. Zinc atom is having 30. But when zinc atom loses 2 electrons, it turns into a zinc ion stable. And what is the how many electrons it will have? Because zinc is having 30, but zinc ion will have 28 because it lost 2. So which ion is having the same electronic structure as the copper plus 1 or having a 28 electron? So you will mention here as Zn plus 2. An aqueous copper 2 sulfate contain the complex ion, that is like water molecules as a ligand are attached to copper. State how electronic energy level of a copper 2 ion changes when water ligand form this complex. So actually what happened, like there are d orbitals. This is a d orbital, dxy, dyz, dzx, dx square minus y square, and dz square. Now what happened, due to the presence of the ligand, like example water molecules are there, the total energy remains the same, but like say 100 joule. But this splitting happened, some have more energy and some have less energy. This splitting happened, and that splitting caused the splitting of the energy level caused the color change of the ion, like it will show a different color. So the point which you will mention here, you will mention like due to the presence of the ligand, the d orbital, the d subshell split into two groups. One is like the total energy remains same, but the splitting of the d orbital, and that is responsible for the specific color. So the ligands, what it caused, the splitting of d subshell. Not orbital, subshell, because orbital is 2 electron. Even it's a dxy, it's one orbital, but d subshell is having 5 d orbitals, so which they split. Explain how the color, explain how this change in energy level a complex ion to have a different color depending on the ligand. So what actually happened, like the gap between the groups or level different for when different ligands are attached. As a result, what will happen? Electron absorb energy. So specific energy it will absorb to move to a higher, and the color, what it like the color of the complex depend on the gap size. And the color which we see is always a complementary color. It's not like what is absorbed. It is always what is not absorbed. That is the color of the complex we see. So even like copper d orbitals are there. If water is attached at a ligand, the splitting will be indifferent. If ammonia is a ligand, the splitting will be different. Like how it will be different, the gap will be different. As a result, when gaps are different, electrons absorb a specific frequency or wavelength and it jump to a higher, and what is not absorbed will appear as a color of this. Like example, if it is not absorbing green, absorbing all and not absorbing green, so it will appear to be green because it's not like what is absorbed, it is what is not absorbed is a color of the compound. So like copper sulfate solutions appear to be blue in color. Whenever you see a copper sulfate solution, it is blue in color. So blue is not the one which is absorbed, blue is the one which is not absorbed. So same thing happened. So the gap between the d orbital depends on the ligands attached. And as a result, what will happen? They will like different, the gap will be different for different ligands. That is one mark. Then what will happen? How actually we are able to see a color? What is responsible for the color? So electron absorb and they gain energy, specific frequency, and move from lower level to higher level. Or you can say photon or fixed energy to move from the lower to higher level. Then the color which we see, the color seen is due to the remaining frequencies. Or remaining frequencies or remaining wavelength, which is not absorbed, that is responsible for the color. Then state the shape of the, there are like example, if you, there are six ligands are attached, the shape of the complex depending on how many are attached. If there are, and you will always have an even number. If there are six, then the shape will be octahedral. If there are four, then there are two possibilities. Then it might be a tetrahedral or it might be a square planar. Normally the platinum, it's like always a square planar. And then if there are two are only attached, then the structure, it will be linear. So as you can see, there are six attached, six water molecules are there attached with this. So what will be the structure? It will be octahedral. Then we have a complex of a copper which reacted with 1,2-diamino ethane. So it's a bidentate. Like this water is a monodentate ligand. It is replaced by bidentate to produce a complex. All water are replaced. Draw the structure of this complex. Make clear how the ligands form the bond with the copper. Look, first, when water molecules were attached, we were having like copper was there +2, and there was a two lone pairs were there on oxygen. So this each lone pair is trying to form or try to fill that orbital d orbital, that is forming a dative bond. So whenever we don't have to draw this one, I'm just explaining the idea that first it was an octahedral. It will remain octahedral, but because the water is a monodentate ligand, so only one is attached. Only one side it can form a dative bond. But then you are replaced with a bidentate ligand in which nitrogen will have the lone pair. So when we draw the structure for a bidentate, so we just link them, like nitrogen having a lone pair, NH2 is there, then there is CH2, then there is CH2, and then NH2, the lone pair. Then this one is NH2, then CH2, then CH2, and then NH2. And this one also NH2, CH2, CH2, and then NH2. This was a structure. So an idea, because two of the bond are into the plane, two are out of the plane, and two in the same plane. So you should represent that as well. Like if you are drawing an arrow, the dative bond, you can also shows that these bonds, like their planes are also different. So how you can represent the planes are different. So you can represent some of them by the wedge, some of them by the dash. So this one we represent. But not all are in the same plane. Like even for one, this is in, one is in the same plane. This one, and this one is in the same plane, one is out of the plane. So you can represent in this manner, because you have to show that the octahedral geometry is there. That's how we represent. Then when a excess of a hydrochloric acid was added, a chlorocomplex form, write the equation and state the shape. Because water is a neutral ligand, so more are attached. But chloride ion, because they are bigger in size, so they can not attach too many, like the same as the water. So as a result, what will happen, like if your Cu H2O bracket 6 and the overall charge was plus 2, only 4 chloride can displace this 6 water molecule. It will be CuCl, and the charge will be minus 2 on the complex, plus 6 water molecules are there. This is the equation. And what is the reason why, like here 6 water can attach but only 4 chloride? Because chloride ion are larger in size, as well as they have a charge on them, so they are repelling each other. That's why few chloride ion can attach with as a complex as compared to a neutral level. And there are 4 are there. So whenever 4 are there, then it will be a tetrahedron. Even it is like, you can mention square planar as well, but usually it is square. For 4, even for copper one, usually with chlorine it is square planar, but here tetrahedral is also allowed. If it was a platinum complex, then it will be square planar only. Then the reaction of ammonia with solution containing a complex of with water take place in 2 steps. Few drops of ammonia added. First one, what happened? It is an acid-base reaction. Like acid are proton donor, bases are proton acceptor. So here this one is losing proton. 2 protons are lost. That's why it will become 2 OH ion. Because when water loses proton, it becomes OH. And this will form a blue precipitate. When we add an excess, the precipitate and excess of ammonia, the name, the type of a reaction occur in 2 steps, and give a formula. Look, whenever the first reaction, whenever you add even sodium hydroxide or you add aqueous ammonia, the first reaction is always an acid-base reaction. And in some cases, the second reaction is acid-base. Sometimes the second reaction is the ligand exchange. But with ammonia and copper, it is, you have to learn that with chromium, it is always like acid-base reaction. Here with ammonia, when we add an excess, it is a ligand exchange. Like this is the equation for the first reaction, but when second reaction happen or occur, what will happen? Like we have the complex, this was there, and when we add more of ammonia, when more of ammonia is added, this ammonia will displace both of them. So it will be Cu NH3 6, and the charge will be +2. So the first reaction was acid base. Further adding an axis, it will be as the ligand exchange. So name an axis is name the type of a reaction occur in two steps. The first one is always acid base. But with copper and ammonia, the second one is the ligand exchange. And what is the final product? The final product, all this two hydroxide and water molecule are replaced by ammonia. But usually when it do a ligand exchange, it's not like all are replaced. Usually like it's replacing hydroxide ions 2 or 3, but not all of them. That's why you don't usually write all 6 to be ammonia. Normally like 4 are there, so it will be Cu NH3 4 and then H2O, the water molecule 2, and the charge on the complex will be +2 because water are the neutral agent. So first when this happen or occur, it is the acid base, and this complex, the solid which is formed, it will dissolve. So when it dissolve, when we add ammonia, like usually 4, so this replace 2 here and replace 2 of the water. As a result, it will form Cu NH3 4 and H2O2 plus 2 water molecules are there which are released and plus 2 OH ions. So better learn these equations and try to remember that which one is a ligand exchange and which one is acid base. First reaction is always acid base. Describe what you see in each of these two steps. So what we'll observe in these two steps, first, we'll observe a blue precipitate, and then second step, the precipitate dissolve to form a deep blue or a royal blue or inky blue solution. The next part, explain in terms of entropy why the equilibrium constant for overall reaction for aqueous copper 2 ions with ammonia is less than equilibrium constant for copper 2 ion with 1,2-diaminoethane. Entropy, it depends on if the number of the particle increase, entropy will increase. Like here, this one is a bidentate ligand. Like we were having a complex, a Cu H2O 6, and there was a charge, and there we need 3 molecules of NH2, CH2, CH2, NH2, because it's a bidentate ligand. So when the reaction occur, Cu, it will produce like NH2, CH2, CH2, and NH2, and how many molecule? 3. And the charge, it's a neutral ligand, so charge will be same as the charge of the positive ion plus the number of the water molecules, it produces 6. So there are like totals increase, like 4 particles turn into 7. But when ammonia is replacing, you see like NH3 is there. So as a result, what it will form? It will form Cu, acid-base reaction occur 2, and H2O4 is there. This will be solid because there is no charge on this complex, plus 2 ammonium ions are there. They accept proton. So first, this is solid. This one is aqueous. This one is aqueous. Ammonia is there. Aqueous, aqueous, aqueous. So 2 reasons are there. One is uh, increase in the number. Like when you check the number of the particle or increase in number of the particle, that is more for 1,2-diaminoethane compared to that of ammonia. The second is so total entropy of the system increases as the number of the particle increase. But here, this one, there's no change. The second thing you can see here, it is forming an aqueous, where when ammonia is reacting first, it is forming a solid. So entropy decreases rather than increases. Entropy increase as the number of particle increase, or the state will turn like from solid to liquid, liquid to gas, or ions. So this was question 13 from electrode potential and the transition metals.